everyone. My name is Jason Moeller. I'm an educator with the Adventure Science Center, and welcome to our live science for today. Today, I plan to launch some things. So let's go ahead and just get started right away with this device I have here on the floor. If you'll notice, what I have is a small ring and a small red button. I'd like you to watch what happens when I push the red button, but first, let's be scientists and come up with a hypothesis. What do you think is going to happen when I press it? Are you ready? 3, 2, 1. If you guessed it was going to fly, you're correct. But my question is, why does this fly? What causes this to launch into the air? Today, we're going to go ahead and look and find the answer to that question. And our first clue is going to be right here on the table. Can anybody identify what these are? If you said magnets, great job. Now here's the fun part about magnets, right? All magnets, like these ring magnets, have two sides. Our blue side is what we call our south pole, while our red side is what we call our north pole. These poles have opposite what are called charges, and these charges do something rather interesting. If I have a south pole and I bring it too close to the north pole, then I have opposite charges. And what do you think is going to happen when I bring these two charges close together? Do you have your hypothesis? Let's find out in 3, 2, 1. And if you guessed that they attract and they come together, and even if I push this, it's not going to come off, then you're correct, right? Opposite charges do what we call attract. They come closer together. But what would happen if I took, say, a south pole, blue right here, and tried to get it too close to another south pole? We know that opposite poles attract, but what about the same poles? Come up with your hypothesis, and let's find out. Are you ready? Let's try this in 3, 2, 1. And if you said they'd push each other away, you're entirely correct. This is what we call repelling. Repelling is when I have charges that are the exact same, and they attempt to push each other away, just like my two little ring magnets are doing here. And part of the answer to what was happening earlier was, yes, there are magnets involved. But the really big answer is actually going to be electricity. Magnets aren't the only things that can attract and repel objects. Electricity, in the right circumstances, can do it too. If you saw my kitchen pandemic video from Wednesday, you would have seen exactly how this works with our hair. But let's look and use a slightly cooler Van de Graaff generator to be able to show exactly how this works. So I'm going to step right over here. Okay. This machine is called a Van de Graaff generator. If you look closely here inside the plastic tube, you will notice that there is a thin belt that runs through the entire middle of the tube. When I turn the machine on, the belt will go and rub against a brush at the top, and it is going to leave a positive charge right here at the very top of this silver ball. So this silver ball is going to be positive, just like our magnet was. Now, here's where things get interesting. Can anybody identify what I'm holding here in my hands? If you said that these are just cupcake holders or tinfoil cups, you're correct. These tinfoil cups are actually made out of something called aluminum. And we're going to place these cups like a funny little hat right here on top of our Van de Graaff generator. Now, when I turn this on, we're going to get a positive charge right here into the Van de Graaff generator. But the cups that are sitting on top are also going to get a positive charge. So we're going to have a positive charge here and a positive charge here. Two of the same charges. Come up with your hypothesis. What do you think is going to happen to these cups? Do you have your guess? Great. We're going to go ahead and find out. First, I'm going to go and place a safety glove on my hand. We are working with electricity today, and electricity can be dangerous, so we want to make sure that our safety comes first. Because I am a trained scientist, I hope you enjoyed these experiments today, but let's not try any of them at home either. Are we ready? 3, 2, 1, and the machine turns on. And there go the cups flying everywhere and smacking me in the face. Right? That's because our positive charges, just like what we saw with the magnets, repel each other and push each other away. Right? If you want to see attraction, what we're going to do is take the silver ball and get it a little close to this bigger ball. Listen. Did you hear that snap? That snap was because this silver ball actually has a slight negative charge, whereas this ball is more of a positive charge. So the electricity actually jumps from the large ball to the smaller ball and goes ahead and now makes this safe for me to touch. Repelling, as we can see, is quite a bit of fun. My question for you, though, is it just tinfoil cups that we can repel? If you said no, great guess. We're going to have some fun with a couple other objects on this table. The first one is this giant blue pom-pom. Now, I'm going to go ahead and place the pom-pom on top of our Van de Graaff generator. So now instead of a hat, he has a little bit of, well, hair. What do you think is going to happen to this hair when I turn on this machine? Come up with your hypothesis? Are we ready? Once again, I'm going to put the glove on. We're going to turn the machine on. In 3, 2, 1. And as we can see, his hair stands right on end. Now, if we left this machine on, it might eventually go ahead and push the pom-pom away as well. However, it looks like it's staying on quite nicely for the time being. So we're going to turn this off in 3, 2, 1. And you'll notice the hair immediately starts going down, especially when I discharge the Van de Graaff generator. The reason for that is this had a positive charge, but the moment that I went and I brought my negative charge close to it, you get what is called a discharge, which is that tiny snap that we heard earlier. That tiny snap means that the charges are all neutralized, meaning that they are back to 0, and this allows the hair to go and look, well, somewhat normal. Now this works nicely with a pom-pom, but what about real hair? So let's do one final experiment with our real hair, and this is going to be a rabbit fur, and see, does this work the same way with real hair that it did with our pom-pom? So let's go ahead and place this up. Do we have our hypothesis? Do we think this is going to work the same way, or do we think it's going to work different? Are you ready for our last experiment? In 3, 2, 1. And you'll notice it's not as crazy, but yes, hair, real hair, also goes ahead and gains an electric charge. Okay? And again, if we go ahead and we discharge it, watch what happens to the hair. It goes back down. The moment we allow that charge to build up again, though, the hair stands on end. Ladies and gentlemen, thank you very much for joining us for our live science today with the Adventure Science Center. Stay safe, take care, and we hope to see you soon.